Okay, so now let's look at the equations of motion. The ones shall be using some of the examples. So now, equations of motion, they are specifically theory. And then they are saying, consider a body below which accelerates uniformly from an initial velocity u to a final velocity v in a time t. So let's do a graph for that. Realize that we have, that is our graph. A sketch which will help us go about this. So we find that this is the velocity in meters per second, and this is time in seconds. So now you realize that the body is a body which accelerates with uniformly. Now, to accelerate uniformly means it must go in a straight line like that. So that is accelerating uniformly. But where is it going to start from? Now here we have velocity. This is velocity 0. When you start from here, that velocity is 0. But here I've said uniformly from an initial velocity u, that from somewhere here we have an initial velocity, say for example, what? U. And accelerates uniformly. That's what we mean by accelerating uniformly, as simple as that. Okay, to a final velocity v, uniformly to a final velocity v, meaning that where it has reached, that's now the final velocity. Remember that as it has accelerated uniformly, we are moved somewhere up in the column of velocity, and that's the final velocity v. Now, final velocity v, there we are in a time t. Time t, you find that even in the time axis, we have covered a certain time interval t, like that. Okay, good. Now realize that we have some shape in there. This shape is a trapezium, if you can see that. Or someone may look at this. Divide it into two. We have a rectangle, this, then we have a triangle. So therefore, I can call this my A, and I can call that my B. That will come on later. Now, when deriving equations of motion, we know that the first equation comes from definition of what acceleration is. So we shall now say that from acceleration equals to change in velocity over change in time. So therefore, acceleration shall call it A. So A is equal to, now I said in mathematics, the word change means subtracting. So a change in velocity. Velocity changed from u to v. So therefore, it will be v minus u over time, which is now what? T. Now, when you make v the subject, this implies that when you make v the subject, your v will be equal to u plus at. This one here shall call it the first equation of motion. Please, the first equation of motion comes from the definition of acceleration. Then the rest of the two will come from this graph. Okay. Now shall say from the graph, shall now say that displacement equals to total area under the graph equals to total area under the graph, total area under the graph. And what does it mean? Displacement, we use letter S, which will be equal to area A plus area B. That is it, area A plus area B. So the displacement still S will be equal to area A. What is our A? A is here. It is a rectangle. Here. Please, I may put them outside here so you can see. Then you have this triangle of ours. So realize that for this one, from here up to here, you subtract this minus this, u minus this. We want to get this one from here up to here. So u minus 0 will be u. Then this minus this, t minus 0 will be t. Then let's come to triangle. It starts from here. So here I have a u, then up I have a v. We want to know this one here to be now v minus u. You have no answer there. It will just be v minus u. Then from here up to here is t minus 0, will just be minus t. So let's look at this. This is A, this is B. We now get the areas. So the area of A will be equal to a u times t plus a half times, sorry. Yeah, by the way, half, we are very right. A half times the base is t times the height, which is a v minus u. There we are. So now this will be S is equal to ut plus a half t into v minus u. There we are. Please allow me. All right. I think that is okay. That is okay. Let's now proceed. Let's now proceed. All right, so let's move on. Let's go on. Let's go on. You realize that we now have to simplify this. So we have that. So that now that will be, we shall call this one here our, okay, maybe we can harmonize. So multiply through by 2. If you multiply here by 2, and even here by 2, and even this times 2, we shall now have 2s is equal to ut, okay, plus, now multiplying that will be now tv or vt minus ut, like that. Oh, by the way, multiply this by 2, we shall have a 2 there. So we find that 2ut minus ut, shall have that 2s is equal to, 2s is equal to, all right, 2ut minus ut, we shall just get ut plus vt, like that. Or in simple terms, 2s is equal to t into au plus v. Now this one here, we'll call it my equation star. A very important equation which will help us get the rest of the equations. Now, how shall we get the rest of the equations? Remember, we said there are 3 equations of motion. We have one so far. We need the second and the third. Now, to get the second equation of motion, we shall get it from this. You realize that the second equation of motion doesn't have v. So we shall now say that from, now say that put, or shall say put the equation 1 into equation star. Put equation 1 into equation star. This will be 2s is equal to, okay, at into au plus, now we are substituting for v. Substituting for v which is u plus at. Simplify, we shall now have a 2s is equal to multiply. That will be, okay, maybe we can have it as t. U plus u is 2u plus now at. Please, u plus u gives us 2u. The 8 is remaining like that. So now to be 2s is equal to 2ut plus at, but squared. Next, we want to make s the subject. Divide all through by 2. Divide all through by 2. So now we can now have that s is equal to, the 2 cancels there, we have a ut plus, now at squared over 2 is same as just a half at squared. This one here is our second equation of motion. Now still, we are going to use this equation 1. We shall now say from equation 1. Yes, what now in equation 3 doesn't have t. So you make t the subject from equation 1, you make t the subject. So now t will be equal to a v minus u over a. A v minus u over a. So now there you come and substitute still in equation star. Put in equation star. Equation star is this one. So now we shall say a 2s is equal to, all right, we are substituting for t. Okay, maybe I rewrite it, t into u plus v. U plus v. Now this will be a 2s is equal to, now where the t is v minus u over a. Again, times, now u plus v is the same as v plus u. There's no harm with that. Now proceeding, so I want to call off this a. So multiply this side by a, even here also times a. So 2s times a will give us a 2as, which will be equal to a v minus u, then a v plus u. If you're very keen enough, you can expand this, no problem, but I'm seeing a difference of 2 squares, which will mean that a 2as is equal to a v squared minus u squared. Now when you make v squared the subject, it will be v squared is equal to, the u goes the other side, u squared plus 2as as required. And those are the 3 equations of motion.